Hello, welcome back to our intermediate algebra course. We are entering chapter 6. Is about rational expressions. That means fractions. I know you all love fractions, right? And before we will have a review about factorization. Is section 5.7. Is because you're going to need a lot during the simplification of rational expressions on chapter 6. All right, before look at the challenge, what is the weight of the dog, the cat, and the bunny all together? On the first scale, you have the cat and the bunny, 10 kilos. And then the second scale, you have the dog and the bunny, 20 kilos. On the third scale, you have the big dog, the big fat cat, 24 kilos. And what is the weight of dog, cat, and bunny all together? Maybe we can calculate the weight of each one and then sum together, or there is a clever way or a quicker way of finding out. Write down your guesses and we will check it out later. Okay, before talking about section 5.7, a quick review about factorization. When we talk about factorization, you might remember it's the process of breaking down each term into factors. Like if you want to find the greatest common factor of um, um, of an expression, right? We have this expression right here. First, we're going to break down each term into the factors, right? The prime factors. And we will look at each one of the set of factors to find common factors. We have 3 in all of them. We have at least one y in all of them. In this case, if I ask you to factor out the greatest common factor of this expression, you will write down the expression as the multiplication of the common factor, the greatest common factor is 3y, times each one of the terms without the factor, right? If you remove the factor from each one of the terms and move to the front of the parentheses, that's what you have. Remember this? Okay, and another thing that we probably remember is how to factor out trinomials by guessing. This is another quick review. If you have, for example, x squared plus 6x plus 8, you can guess two numbers, and the trick is those two numbers, if you add the two numbers, it's equals to this coefficient. If you multiply the two numbers, is equals to this constant. Okay, so what are the two numbers that if you add equals to 6, if you multiply equals to 8? Well, this one is pretty simple. 2 plus 4 is 6. 2 times 4 equals 8. So we can break down this expression as the multiplication of two binomials, x plus 2 times x plus 4. If you want to check, apply FOIL method, and you will get the same trinomial, right, as the original one. That's we're gonna call this factoring method as educated guess or guessing the numbers. Okay. All right. Now let's talk about factoring by special products. This is some special formulas that will be helpful to factoring out kind of some expressions that looks complicated but are not. Let me show the first formula that we're gonna use is the perfect square trinomial. We will use those two formulas here. Write down in your notebook. I'm not going to explain right now. We will use those formulas and probably going to understand better on the examples. Okay, so let's say we want to factor out x squared plus 12x plus 36. Then you can say, well, I know how to factor out this one because I can guess two numbers that multiplied is equals to 36, and two numbers, the same two numbers added is equals to 12. And think about two numbers that multiplied is 36, and if you add equals to 12, and you're going to come to the conclusion that this might be what? If you're not sure, make a list. All numbers that multiplied is equals to 36. Like we can say 2 and 18, 36, 4 and 9, 36, 6 and 6, 36. And wait, we have our answer here, because 6 plus 6, 12, 6 times 6, 36. We can write down, we can represent this trinomial as the multiplication of two binomials, and they are actually the same. The numbers are the same, so we can write this as a perfect square. Sorry, x plus 6 is squared. Right? Now, let me show another way of solving this by using our formula. Erasing all this, and we're going to go back to the formula. A squared plus 2ab plus b squared equals a plus b squared. Okay, let's compare the formula with the expression that we have. So a squared plus 2ab plus b squared. We need to identify here which one is a, what is the value of a, what's the value of b. Okay, looking at the question, we can clearly see that a needs to be x, and we also it's pretty clear that b needs to be 6. Now let's check this. 2 times a times b times plus 2. If a is x, let's plug in x. If b is 6, let's plug in 6. All right, and we have 12. 12, 2 times 6, 12, 12x. All right, by comparing and finding a and b, we managed to identify that this is a perfect square. So we can write as a, the formula is a plus b squared, right? So the answer will be a is x, b is 6 squared. That's what you're looking for, right? So that's how we use the formulas of perfect square trinomials to factor out this expression that we identified as a perfect square. Let's work on the next example. Factor out 16x squared minus 8xy plus y squared. This one, we will not be able to use our guessing method, remember? Because we have a 16 here in front of x squared. And for our guessing method, we need to have nothing, or that means 1 as a coefficient of x squared, right? Let's check if we can use the perfect square trinomial formula. A squared, this is minus, so minus 2ab plus b squared. Comparing, well, we have to find an expression that squared is equals to 16x. Maybe 4x, it works. Yes, 4 times 4, 16, x times x, x squared, perfect. B is easy, is y squared. Okay, so we have A, we have B. Let's check if this term here in the middle is the same as 2ab. Minus 2 times a is for x and b is y. Perfect, because 2 times 4, 8, 8xy is the same as the expression on the question. The formula, let me write down, this is the formula, and is equals to a minus b squared. The answer will be a for x minus b y squared. All right, another example. Again, we have the number 4 in front of m fourth. And another thing, we don't have m squared. We have m to the power 4. So let's check. The guessing method will not work. The guessing method will be very good later in several homework questions. We will be able to apply, but not on this example. So let's find out if we can represent this as a square. 4m to the power 4. Okay, we can write down here 2m squared. This is squared, then we have 2 times 2, 4, m squared times m squared, m fourth. Perfect. Let's check b. Look, b is 1, because 1 squared is always 1. And let's check if we're going to have 2 times a times b. 2 times 2m squared times 1. Perfect. This is the same thing as negative 4 times m squared. The formula says this is equals to a minus b squared. So a is 2m squared, b is 1 squared. That's the final answer. That's how we factor out 4m to the power 4 minus 4m squared plus 1. Okay. Next example, factor out 25x squared plus 50x plus 9. We cannot use the guessing method, but maybe. Let's check if we can use the formula. Okay, the formula is a squared plus 2ab plus b squared. And the formula is equals to a plus b squared. This is the formula. And we will check if the expression that we're working on complies with the formula. If we make a equals 5, a squared, equals 5x, okay, 5x squared equals 25x squared, perfect. If we make b equals 3, 3 squared equals 9, okay, okay. Now we have to check this term here in the middle. So plus 2 times a is 5x, b is 3. And wait a minute. 2 times 5, 10 times 3, 30. We will have 30x here. 30x is not the same thing as 50x. That means we cannot use is not a perfect square. Okay, we cannot use the formula of perfect square trinomials to factor out this expression. On the next example, I will leave for you to finish. I'm just going to start. We have to identify a. The formula is a squared minus 2ab plus b squared equals a minus b squared. And a is, look, we have 16. So 4x squared, 4x squared is 16. B is y, okay, squared. Now check to AB and find the answer. Okay, that's for you to finish. Is it factorable? Does it comply with the formula? Check if 8xy is going to be equal to 2 times a times b. Another method or another formula that we can use is the difference of two squares. Let's go straight to the formula. It looks like that, and don't memorize any of those formulas. Just write down in your notebook, and you can always check. Let's see how we apply. The formula is a squared minus b squared. If we have a difference of two squares, we can write that as a multiplication of two binomials, a plus b times a minus b. Okay. Identify a. Okay, here is easy. A is x. Identify b. B is 3. And we can write a, x, plus b, 3, x minus 3. That is the final answer. Okay. I think this case now is easier than first one. The first one, the perfect square trinomial, you have to work out the term in the middle and compare. This one, no, is a straightforward comparison, is much easier, I think. What about now? 4x squared minus 1. We need to identify a, we need to identify b, and it's going to be a plus b times a minus b, right? A will be, okay, 2x. 2x squared is 4x squared, okay? 1 squared is equals to 1. So a is 2x plus 1 times 2x minus 1. That's the final answer. See, much quicker. Can you identify now which one is a? What's the value of a? What's the value of b? Look, a, pretty easy, y squared. B is going to be a fraction. A fraction that squared is equal to 16 over 25. If you guessed it 4 over 5, yes, that's the right answer. So this is equals to a plus b times a minus b. Nice. Well done. Next example. And it looks a bit confusing now because we have 36a squared minus 49b squared. I'm not going to finish this one. I'm going to leave it for you to finish. But let's identify a and b. First, remember, there's the formula. And the formula is a squared minus b squared equals a plus b times a minus b. And there is the expression that we are working on. It also has a and b, but it's a different a and b, okay? So don't mix up things. Let's say the blue a is going to be, let's call the red a, 6a, because you're going to have a square. Okay. Can you understand this? So b, the blue b, is equals to the red b of the expression 7b, because this is 7 times 7, 49, b squared. When we square we have 49b squared. Okay, and plugging into the formula, 6a squared minus 7b squared equals, and that's, let's call blue A, blue B. Can you understand? It's confusing. We have the B, A and B of the formula. It don't mix up with the A and B of the expression that we're working on. 6a plus 7b times 6a minus 7b. Okay, that's the final answer. Cool. Oops, now the example is factor out 4x cubed minus 49x. And I'm confused because the formula is a squared minus b squared, right? And we have x cubed. How can we use? I can promise this is the formula we will have to use. But there's one tiny thing we have to do before using this formula. Look, try to find one greatest common factor that you can factor out. Yes, you can see both have x, so we can factor out x. X times 4x squared minus 49. Now it's kind of easy because you can write this as, let's use a different bracket, 2x squared minus 7 squared. Okay, and inside this bracket we can apply the formula to break down as a plus b times a minus b. Please finish this example for me with the final answer. You can do by yourselves. And another one that I will leave to you. You can finish this one. I will just show what is a, 7 squared, and b is x squared. And use the formula to find out the answer. That means a plus b inside parentheses times a minus b inside parentheses. Another example, and a is going to be x plus 1, no problem. B is 3, okay. And if we find the answer applying the formula, right? A is x plus 1 plus b, 3, times x plus 1 again, minus b, 3. We need to simplify. Don't give this as the final answer because you still can combine like terms inside the parentheses, right? So equals x plus 4, 1 plus 3, 4, times x, 1 minus 3, negative 2. This is going to be the final answer in that case. All right, I think this is the last example. Now we're going to work on the next case, or the next formula is the sum or difference of two cubes. If you have a cubed plus b cubed or a cubed minus b cubed, there is a formula for each one of those cases that you can use. Let's see examples. The formula is a bit long, but don't get scared about it. Because I think actually this is one of the easiest ones to identify. If you have both cubes, let's see, look. X cubed, we need to have a cubed plus b cubed. Of course, a is going to be x, and b, yes, 1, because 1 cubed is equals to 1. And then you apply the formula, a plus b times a squared minus ab plus b squared. Don't need to memorize. You can go back and check the formula. Yes, And it's better because sometimes you can mix up. No, make sure that you're using the correct formula. A is x, b is 1, a squared x squared minus x times 1 plus b squared is 1 squared. Just a tiny simplification we can make. X plus 1. That's the final answer. Okay, now see, you can identify the cube, y cubed, and 64, 4 cubed. So we have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. This is the formula, okay? Formula. And applying the formula here. A minus b, y minus 4. A squared, y squared. Plus a times b, y times 4 or 4y, right? Plus b squared. b is 4. 4 times 4, 16. This is the final answer. This one I will leave for you to finish, but we will identify a and b of the formula. We need to have a3 plus b3, right, to be able to apply the formula. And a is going to be 64 is 4 times 4 times 4. So 4y cubed, yes, this is 64y cubed plus 1 cubed. Now finish plugging here the formula by using a equals 4y and b equals 1. Wait, this is very confusing. Now we have power of 6 and I don't know how to solve this one. Let's think a little bit because maybe we can find a and b. We need to have difference of two cubes, right? Maybe if we write down here x, y squared. Look, it works. X, y squared, inside parentheses, the whole thing cubed, is equals to x cubed times y, 2 times 3, 6, y to the power 6. Nice. And 27 is 3 times 3 times 3, means 3 cubed times z. Okay, now you have a, you have b, you can apply the formula. That's another work for you. Plug in a equals xy squared, plug in b equals 3z into the correct formula to find the answer. Okay, that's all for now. We are ready to enter chapter 6. Will be the next meeting. And what is the answer for the challenge? What is the weight of the dog, cat, and bunny all together? Again, you can work out the weight of the bunny and the cat, the dog, then sum up all the weights. It will be kind of a lot of work. Or you can be kind of clever. If you add all these three weights, right? 10 plus 20 plus 24. 10 plus 20 plus 24. This is going to be the weight of 2 cats, 2 bunnies, and 2 dogs. If you want the weight of 1 cat, 1 bunny, and 1 dog, just divide 54 by 2. And you're going to have the answer. The answer is 27 kilos. 27 kilos, because you're going to divide 54 by 2, you find 27. All right, and thank you for watching. On the next meeting, we will start chapter 6. I hope to see you soon.